So we've solved systems of equations in two variables. We should be pretty good at that by now. So now we're going to get into systems of equations in three variables. So in all these examples today, you're going to see three variables: x, y, z, r, s, t, whatever. And we're going to need to find all three, the variables for all three and how they work with the system. The idea is to get both sides of the equation to be equal for all three equations. So what numbers do we have to come up with for x and y? Just to recall, just a quick review here. Obviously, there's only two variables, x and y here, because I just want to review how the process works. So here you need to get x or y to drop out. We do have to use our skills from the two variable in order to do the three variable. So I see a negative and a positive here. I want to get the y's to drop out, so I'm going to multiply by 2. The second equation by 2. I'm going to leave that first equation alone. So that first equation is just going to carry down 5x minus 2y equals 5. And then my second equation becomes 4x plus 2y equals 4. And now I'm ready to use my addition method, which is to add the equations together. Now, like I said, we purposely put 2 there because we want the 2 y's to drop out, positive 2y, negative 2y. Add what's left, 9x equals 9, and then divide by 9, x equals 1. Okay, so now that we have x equals 1, we can find y because we know that 2x, I'm just taking the original, 2x plus y equals 2. You could take either one of the originals. Plug in a 1, 2 times 1 plus y equals 2. 2 plus y equals 2, and y equals 0. Okay, so I believe we're good there. All right, so we have the system would be 1, 0. 1, 0 would be the solution there. Okay, so now we're moving on to systems in three variables. So now if you have three variables, it requires three equations. And that's kind of what you have here. But what you need to do is take it two equations at a time. So I'm looking for positives and negatives of the same number to try to get them to drop out, kind of like how we did before. You have to kind of examine what you have. What I'm looking at here is I have a positive r and a positive r, so that's not going to drop out. I have a positive s and a negative s, that would drop out. And I have a positive u and a negative u, and I have if I do the first two equations, I have a positive u and a negative u. So we have some possibilities here, and we have some options. What I'm going to do is I'm going to take these last two equations here, for example, and just focus on those. Forget the first one for a second. You could take any two you want. So if we take these two only and combine like terms, add those two together, I'm already set up with cancellations here. The u minus u is a 0, and the s minus s is also 0. So I'm left with just r equals 6. Again, r, because there was no r here, so I have r. S minus s is nothing, 0s, and u minus u is 0u. Those dropped right out. 4 plus 2 is 6, and I already solved for one variable. I already got r equals 6. So this is one of the easier ones you would maybe be required to do. All right, so now what do I know? I know r equals 6. So what I'm going to do is I'm going to plug that right back into here. All right, so once you have one, plug it back in. So I have s plus u equals 4. And then I know r is 6. So 6 minus s minus u equals 2. So subtract 6 from both sides, and that gives me negative s minus u equals negative 4. The problem is, if I combine these two equations, I'm not going to have any variables left at all, you see. So because s and u are both going to cancel out. So that's not really going to help us. So what we need to do here is we need to get the r here. We know that r is 6, so I have 6 plus 2s minus u equals 8. Subtract that 6 over, and I get 2s minus u equals 2, if I just subtract the 6 over there. All right, so I have 2s minus u equals 2. That's my new first equation. My new first equation is now that. All right, so let me pick one of these How about this right here? I'll use that one. You can use any two equations you want. Now, why did I pick that one? Well, I have a minus u here and I have a positive u here. So I know that's going to drop right out and I'm going to get 3s equals 6. So now I already know r, and now I divide by 3 and I have s equals 2. So now I know s and I know r. Well, s plus u, and I know I'm kind of all over the place here, but s plus u equals 4, so 2 plus u equals 4, and now I know that u must equal 2. So now I have my system. I have r, I have s, and I have u, and we're going to write it as a coordinate, except it'll be, you know, you write x, y, x comma y. We're going to write r comma s comma u. So r comma s comma u is 6, 2, 2. So the solution is 6, 2, 2. All right, so you have to kind of manipulate. Here's the steps. If you forget what you're doing, this is the procedure for you. We're going to kind of skip that over. We're going to go right. We got just 2 more examples to do on the video here. This one's kind of ugly, and you may need more room. If you need more room, just go to a separate sheet. But actually, I think there's room on the back page if you need to go to that. So here, I have a system, and you can see there's more stuff going on here. We don't have anything that drops out nice and easy. So what we have to do is we have to take 2 equations at a time. So we're going to take these 2. So that's going to be, we're going to kind of ignore this one for now. Don't cross it off. I'm just crossing it off on here. All right, so we're going to ignore that. So what we're going to do is multiply this one by a -5. And the reason why is because I can get a 5x minus 5x. Like we did, you kind of did that in another lesson. So we're going to have 5x minus 2y plus 3z equals 0. And then minus 5x plus 25y plus 10z equals 20. So now my x drops out, and I have 23y plus 13z equals 20. Okay, great. The problem is I didn't solve for y or z. I don't have anything yet. So sometimes you have to use 2 equations to get something to cancel out just to get down to one equation that has y and z in it. So now what I'm going to do is I'm going to go back to my original equation that I had originally crossed out. And again, you're not going to be an expert by watching this video. You're just going to get some information to help you with class tomorrow. So now I'm going to take the first equation, equation 1 and equation 3, 2x plus 3y plus 4z equals 2. And I'm going to take that bottom equation, x minus 5y minus 2z equals -4. All right, and I'm going to try to get the x to drop out again, because if I have a yz equation here and I get another yz equation, I can do a system on the yz equations. All right, so we're going to do multiply by -2 here. So I have 2x plus 3y plus 4z equals 2. And this bottom equation is going to become -2x, which is going to drop out, plus 10y plus 4z equals 8. So now I have 13y plus 8z equals 10. All right, I just want to make sure I did not make any mistakes before we move on, because obviously we wouldn't want that, because then we're going to be going crazy here. So I have 23. Let's see, 23y. Let's see, 23y plus 13z equals 20. 20 equals 10. 13y equals 20, and then I have 13y plus. Okay, we're good. So these 2 equations now, since it's a yz, I can now solve that system, kind of put them together. So it's 23y plus 13z equals 20, and then 13y plus 8z equals 10. And now I'm solving this system, but nothing drops out, y and z. So this one's about, this is about as crazy as it would get. I'm going to kind of go down into here. You probably have more room than I have. So now, how can I get them to drop out? Well, these are going to be huge. But 8 and 13, that'll work pretty good. I can multiply this one by negative 13, and I can multiply this one by negative 8. And that would get the z's to drop out. So that's going to give us, let's see, that's going to give us, we want positive 8 here, positive 8. So because we want a positive and negative. All right, so that's going to give us 184y. I did this ahead of time just because I knew it was going to get crazy. 184y plus 104z equals 160. I know these numbers get big, but then they kind of cool down. Then you get minus 169y minus 104z, which is what we wanted. See that? Equals negative 130. So there we go. That drops out, and you're going to get 15y equals 30, and then you get y equals 2. All right, so we have a y equals 2. Excellent. All right, now that we have y, we can now use you can use any of these equations, really. You got 3 here and you got 2 here. We're just going to use, you wouldn't want to use a 3 variable, you would use a 2 variable equation. I know that, this one looks pretty easy right here. Let's use this one. Okay, so we have 13y plus 8z equals 10, and I know y. Okay, so I'm going to go 13 times 2 plus 8z equals 10. 26 plus 8z equals 10. Subtract 26 from both sides. 8z equals negative 16. And divide by 8, so z equals negative 2. So now I have z, I have y, and then of course you could find x. Go back to one of the original equations, it doesn't matter. Let's just take the original. Let's just take 2x plus 3y plus 4z equals 2, and we know y and we know z. All right, so 2x plus 3 times 2 plus 4 times negative 2 equals 2. 2x, 6 minus 8 is negative 2, equals 2. Add 2, 2x equals 4, and x equals 2. So I have 2, 2, and negative 2. That's the solution to my system. 2, 2, and negative 2. All right? All right, last example here. And this one's a little different. They want us to write the equation of a parabola that goes through these 3 points. It's kind of weird. It seems like it has nothing to do with what we're doing, but it actually does. Because these points are x, y, x, y, x, y. So we can write this equation 3 times using 3 different x's and y's. So I'm going to write, y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. Because I have 3 different points, 3 different x's, 3 different y's. So literally, you're writing the equation 3 times. Here's our system. Now fill in what we know. We know y. So for the first one, I'm just going to draw an arrow here. Y is 6. See? 6 equals a times 1 squared plus b times 1 plus c. And then my second equation, I'm going to use this point 320. 20 equals a times 3 squared plus b times 3 plus c. And then I'm going to use this point for my last equation. 15 equals a times negative 2 squared plus b times negative 2 plus c. Now we're going to clean these up. Clean up our system a little bit here. All right, we're going to have, and I'm going to kind of shoot over here. All right, 6 equals a plus b plus c. Okay, 20 equals 9a plus 3b plus c. And then 15 equals 4a minus 2b plus c. All right, so what I'm going to do to make this a lot easier to solve, this is a little trick. I'm going to multiply this middle equation by negative 1. Why? Because I noticed c. And as long as I can get a negative c here, I can combine these two equations and combine these two equations to get two new equations that don't have c. So I'm gonna go over here, and then we're gonna have 6 equals a plus b plus c, and this is gonna be negative 20 equals negative 9a minus 3b minus c. Reason I'm doing that is my c's drop out, and I get negative 14 equals negative 8a minus 2b. And that gives me one equation that's going to help me solve for a or b. Now taking this middle equation here, this middle equation, negative 20 equals negative 9a minus 3b minus c, and do it with this one, 4a minus 2b, excuse me, plus c. C's cancel, and I get negative 5 equals negative 5a minus 5b. All right, so now I have a system, a two-variable system. All right, I'm going to extend our page a little bit here. So I have these two right here. I have negative 14 equals negative 8a minus 2b, and I have negative 5 equals negative 5a minus 5b. And now I will solve my regular two-variable system. Looks like 5 and 2, that's a good one to use. 5 here and 2 here, but we need one of them to be negative. So let's do a negative up here. That's going to give me 70 equals 40a plus 10b. Then that's negative 10 equals negative 10a minus 10b. My b's drop out. 60 equals 30a. Divide by 30. A equals 2. And then, of course, you can plug it in here. Let's go with, just plug it in right here. Why not, right? Negative 5 equals negative 5 times 2 minus 5b. Negative 5 equals negative 10 minus 5b. Add 10. 5 equals negative 5b, so b equals negative 1. So b is negative 1, a is 2, and remember, back to the original, a plus b plus c equaled 6. If you add a, b, and c, you should get 6. So let's go with that. That's an easy one. A plus b plus c equals 6. 2 minus 1 plus c equals 6. 1 plus c equals 6. C equals 5. All right, we got a, b, and c, and so now we can write our equation. Originally, what they wanted us to do, y equals ax squared plus bx plus c. Y equals 2x squared minus 1x plus 5. That would be our answer because that's the parabola that has the A, B, and C values that we found here. We're going to do another one of those tomorrow in class. I'll see you then.